In this video, we will take a look at the properties of cyclic quadrilaterals. First of all, let's take a look at the meaning of cyclic quadrilaterals. Suppose we have a circle here. When we pick any 4 points on the circumference, we can form a quadrilateral. And this quadrilateral is called a cyclic quadrilateral. That means for a cyclic quadrilateral, all the vertices should lie on the circumference. Therefore, these 2 quadrilaterals are not cyclic quadrilaterals because the 4 vertices do not lie on the circumference of a circle at the same time. On the other hand, these 3 quadrilaterals are all cyclic quadrilaterals because the 4 vertices lie on the circumference at the same time. For a cyclic quadrilateral, there is a special property for its opposite angles. Later it can be proved that the sum of the opposite angles of any cyclic quadrilateral is always equal to 180 degrees, and this property is known as opposite angles cyclic quad. Quad, QUAD, stands for quadrilateral. Now let's take a look at the proof of this property. First of all, we can join 2 lines to the center like this. If we consider the angles at center, then we can conclude that A is equal to 2x because angle at center twice angle at circumference. Similarly, B is equal to 2y. Furthermore, when we consider angles at the point, we can conclude that A plus B is 360 degrees. As a result, we can get that 2x plus 2y is 360 degrees, and therefore x plus y must be 180 degrees. That's the proof of this property. On the other hand, if the cyclic quadrilateral looks like this, we can still prove that the sum of the opposite angles x and y is equal to 180 degrees. The proof is exactly the same as before. We just join the lines to the center, and A is still equal to 2x, B is still equal to 2y, so everything is the same, and that's why x plus y is equal to 180 degrees. That means according to this property, for any cyclic quadrilaterals, the sum of the opposite angles is always equal to 180 degrees. Now let's take a look at another property of cyclic quadrilaterals. When we extend one of the sides of this quadrilateral, we can obtain the exterior angle of this cyclic quadrilateral. We have already learned that x plus y is equal to 180 degrees because of the opposite angles of cyclic quadrilateral. Furthermore, z plus y is equal to 180 degrees because of the adjacent angles on straight line. As a result, we can conclude that x is equal to z. Therefore, for any cyclic quadrilaterals, the exterior angle A is always equal to the interior opposite angle B. This property is referred as exterior angle cyclic quad. To conclude, we have learned 2 properties of cyclic quadrilaterals. One is about the opposite angles of cyclic quad, and the other one is about the exterior angle of cyclic quad.